Let us go for the problems on the ray optics. That is, first problem. A prism of angle 60 degree. That means A is given. This is a 60 degree. Produces angle of minimum deviation of 40 degree. That is, D is equal to 40 degree. What is its refractive index? They are asking us to calculate the refractive index of the prism. Calculate the angle of incidence and angle of incidence of the prism. Generally formula ಏನಿದೆ ಅಂತಂದ್ರೆ n is equal to sine of angle of incidence divided by sine of angle of refraction. That is a Snell's law. For the prism, this can be done as sine of a plus d divided by 2 whole divided by sine of a divided by 2. So illi I, this is going to replace the I, therefore we can write I is equal to a plus d divided by 2. A is given, that is 60, plus D is given, that is 40. This is divided by 2. This is going to be 100 divided by 2, which is a 50 degree. So angle of incidence baratha 50 degree. And to calculate the refractive index of the material, that is sine of A plus D divided by 2. This is already calculated. Let me go for this. 50 degree divided by sine of A divided by 2. A is 60 degree. 60 divided by 2 antandre 30. Therefore sine of 30. So this is going to be 0.7660 divided by 0.5, which is equal to 1.53. This is the refractive index of the material of the prism, and this is angle of incidence. Okay. Let's go for the second problem. That is the two lenses of focal length 0.20 meter and 0.30 meter are kept in contact. Let us consider there are two lenses, lens 1 and lens 2 here. These two lenses are kept in contact. Find the focal length. Let us consider this as having the focal length f1, and this is going to have the focal length f2. Find the focal length of the combination. That is, we have the formula 1 upon f effective, that is a combination, is equal to 1 upon f1 plus 1 upon f2. We are given with the f1 value, that is 0.20 meter, and f2, that is 0.30 meter. Then to calculate the f effective, that is the focal length of the effective combination, then 1 upon f effective is equal to 1 upon f1 plus 1 upon f2. After simplifying this, we can write this f effective as f1 f2 divided by f1 plus f2. Substitute the values, that is 0.20 into 0.30 divided by 0.20 plus 0.30. We'll get 0.06 divided by 0.50. Then f effective is going to be 0.12 meter. Okay. Nantra in calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದರೆ to calculate the power. To power, that is P is equal to 1 upon f effective. Then this is going to be 1 upon 0.12, which is equal to 8.33 diopter. This is the final answer. Let us go for the third problem. This problem find the change in the focal length of the convex lens of focal length 20 centimeter. They are telling that there is a lens which is going to have the focal length of 20 centimeter. Let me consider this focal length is in air, that is 20 centimeter. When it is immersed in water, either lens na tagondogi neeralli dip madidre, which is going to have the refractive index of 4/3. That water is going to have the refractive index of refractive index of water and glass are 4/3 and 3/2 respectively. That means ಇದನ್ನ ತಗೊಂಡೋಗಿ ನೀರಲ್ಲಿ ಮುಳುಗಿಸಿದಾಗ ಅವಾಗ ಬರ್ತಾ ಇರುವಂತ ಹೊಸ ಫೋಕಲ್ ಲೆಂತ್ ಏನು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ನಂತರ ಚೇಂಜ್ ಇನ್ ದ ಫೋಕಲ್ ಲೆಂತ್ ಅಂದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಇನ್ ವಾಟರ್ ಮೈನಸ್ ಅಥವಾ ಡಿಫರೆನ್ಸ್ ಆಫ್ ಫೋಕಲ್ ಲೆಂತ್ ಇನ್ ಏರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಲೆಟ್ us go for the formula. This is what all given things are there ನೋಡೋಣ. n water the refractive index ಕೊಟ್ಟಿದ್ದಾರೆ, that is 4/3, and n glass, that is 3/2. they have given, this is 3/2, and the refractive index of glass with water, it is nothing but Nz divided by Nw. You can calculate by using this data, that is 3/2 divided by 4/3, it will be 9/8. So let us use the formula 1 upon f is equal to n minus 1 into the bracket 1 minus r1 minus 1 upon r2. So this is the formula called as a lens maker formula. This formula use ಮಾಡೋಣ. 1 upon F air is equal to n minus 1 into the bracket 1 upon R1 minus 1 upon R2. Similarly, if you take this lens in the water ಒಳಗಡೆ ಹಾಕಿದ್ರೆ ಅವಾಗ ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ 1 upon F water is equal to refractive index of glass with respect to water minus 1 into the bracket 1 upon R1 minus 1 upon R2. So this whole thing will get cancelled out and the remaining is 1, that is ಇದನ್ನ ಮೇಲ್ಗಡೆ ತಗೊಂಡೋದ್ರೆ this will go to the numerator, therefore F water divided by F in air is equal to, this will keep as it is, n minus 1 divided by n glass with respect to water minus 1. So substitute the values of n here, 3 by 2 minus 1, and this is going to be 9 by 8 minus 1. If you calculate this, either 3 by 2 minus 1, this is 1 by 2, and 9 by 8 minus 1, it is 1 by 8. ಇದನ್ನ ಮೇಲ್ಗಡೆ ತಗೊಂಡೋದ್ರೆ this will be 8 by 2. 8 by 2 is nothing but 4. So Fw upon F air, that is focal length in water divided by focal length in air is that is 4. ಈಗ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಏನಿದೆ F in water ಬೇಕಾಗಿದೆ, that is equal to F divided by F in air into 4. So therefore this is 80 centimeter. Then the meaning of this is the focal length of the lens in water is 80 centimeter, whereas the focal length of lens in air was 20 centimeter. Then change in the focal length is F in water minus F in air. This is 80 centimeter minus 60 centimeter, which is going to be 20 centimeter, which is going to be 60 centimeter. This is the focal length. The focal length is going to be 60 centimeter. Okay, let us go for the next problem. That is, a small bulb is placed at the bottom of a tank. Elon tank ide. Okay, so let us go for this very clearly. Assume that there is a tank. This is the tank. Okay, at the bottom of a tank containing water to a depth of 1 meter, a bulb is placed. Andre illello one kade ಒಂದು small bulb ide anta itಕೊಳ್ಳಿ. So this is the bulb which is at the depth of 1 meter. So the depth is given 1 meter. ಹಂಗಾದ್ರೆ ಇಲ್ಲಿಂದ ಇದರಲ್ಲಿ ನೀರು ಇಲ್ಲಿವರೆಗೂ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. So ಹಾಗಾದ್ರೆ ಇದು depth ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. This depth is 1 meter. Okay. Find the critical angle for water air interface. Let us consider there is the last ray which is coming from here. ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಂಗಲ್ ಇಂದ ಏನಾದರೂ ಇಲ್ಲಿ ಬಿದ್ರೆ ಅದು ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗಿ ಒಳಗಡೆ ಬರ್ತಿತ್ತು. ಹಾಗಾದ್ರೆ this is the critical angle. ಇದಕ್ಕೆ ನಾವು ಏನು ಹೇಳ್ತೀವಿ, critical angle ಅಂತ ಹೇಳ್ತೀವಿ. This is critical angle here. This angle must be this one because these two are parallel here, and ಇದು angle same ಆಯ್ತು. Okay, find the critical angle. This we have to calculate of the water and air interface. Also calculate the radius, diameter. Radius calculate ಮಾಡಬೇಕಾ, diameter of the area of the circular bright patch. ಇದರ ಮೇಲ್ಗಡೆ ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ ಸರ್ಕ್ಯುಲರ್ ಬ್ರೈಟ್ ಪ್ಯಾಚ್ ಬಿದ್ದಿರುತ್ತೆ. ಹೀಗೆ ಇದರದ ರೇಡಿಯಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಇದರದ ಡಯಾಮೀಟರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಆಮೇಲೆ ಇದರದ ಏರಿಯಾ. ಫಸ್ಟ್ we will try to find out the radius. To find out the radius, let us go for this one. The given thing is radius, what is that? A refractive index is given, that is water is 4 by 3. So refractive index of water is 4 by 3 anta aita. So using the formula, that is the relation between n and c, refractive index and critical angle is given by n is equal to 1 upon sin c. So using this formula we can calculate the value of c, that is the sin c is equal to 1 upon n agata. C is equal to sin inverse of 1 upon n. So this can be written as sin inverse of, the value of n is 4 by 3. If you take it to the numerator, that is going to be 3 by 4. So this can be written as sin inverse of 0.75. Okay, the sin inverse of 0.75 is equal to, that is 48 degree 36 minutes. Using logbook or else trigonometric table, you find out this, that is 48 degree 36 minutes barata. Then go for the calculation. Let us go for this triangle. Let me call this as O, this as A, and this as B. From this triangle OAB, this is a right angle triangle, then tan of C, that is tan of this angle, can be defined as opposite upon adjacent. Opposite is nothing but R, adjacent is nothing but height of this water. So ಹಾಗಾದ್ರೆ r by h ಆಯ್ತು. r is equal to ಏನು ಬರೀಬಹುದು, ಇದನ್ನ h ಈ ಕಡೆ ತಗೊಂಡ್ಬಂದ್ರೆ h tan theta ಅಂತ ಬರೀಬಹುದು. h is given 1 meter and tan of theta, that is C, tan of C is nothing but 48 degree 36 minutes. So if you calculate this one, this is going to be 1 into 1.1343, 1 into 1.1343, that is 1.1343 meter. You got the value of r now. ಈಗ r ಗೊತ್ತಾಗಿದೆ, diameter find out ಮಾಡ್ಲಿಕ್ಕೆ ಏನಿಲ್ಲ, that is diameter is equal to 2 times of radius. So therefore you are going to get 2 into 1.1343, that is 2.26. To calculate area, we will use the formula pi r square, because the patch here is a circular patch. A circular patch in the area ಏನಾಗಿರುತ್ತೆ, pi r square ಆಗಿರುತ್ತೆ. Therefore pi r square ಅಂತ substitute ಮಾಡ್ಕೊಂಡ್ರೆ 3.142, that is pi into r square ಅಂದ್ರೆ 1.1343 other square. This is equal to 4.042 meter square. That means the area of this patch is 4.042 meter square and radius is 1.134 and diameter is 2.2686 meter. Hope you got this. Okay, e problem nodona. A transparent cube of side 24 centimeter. There is a cube of a side, say 24 centimeter. ಈ ತರದ್ದು ಒಂದು ಕ್ಯೂಬ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಇದರದ ಸೈಡ್ ಲೆಂತ್ ಇದೆ 24 centimeter. That means this is 24 centimeter from here to here. Contains a small air bubble inside, that is ಇದರೊಳಗಡೆ ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಒಂದು air bubble ಇದೆ. So apparent depth when viewed through a face, one face, is a 9 centimeter. Let us call this as phase 1 and this as phase 2. ಇಲ್ಲಿಂದ ನೋಡಿದಾಗ ಇದು ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಇಲ್ಲಿ ಕಾಣ್ತಾ ಇದೆ, that is this is appearing to be at the distance of 9 centimeter. And when viewed from the opposite face, it is about 7 centimeter. ಇಲ್ಲಿಂದ ನೋಡಿದ್ರೆ ಇದು ಅನ್ನಿಸ್ತದೆ ಇಲ್ಲಿಂದ 7 centimeter ಇದೆ ಅಂತ. Okay, what is the actual distance of the bubble? That means this distance you have to calculate either from this face or else from this face. ಯಾವ್ದಾದ್ರು one face ಕಡೆಯಿಂದ calculate ಮಾಡೋಣ. From the first face. Okay, they are mentioning that it is from the first face. That means from the first face we will solve for this one. Either distance ಎಷ್ಟಿದೆ ಅಂತ ಈ ಕಡೆಯಿಂದನೂ calculate ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. Total it is 24 centimeter. Then if you calculate this value, 24 minus this is going to be ಈ ಕಡೆಯಿಂದ value ಬಂದಿರುತ್ತೆ. Okay. So also calculate the refractive index of the material of the cube. ಈ cube ಇಂದ ಏನು material ಇದೆ ಇದರ refractive index ನ find out ಮಾಡ್ಲಿಕ್ಕೆ ಇದೆ. Let us consider x is the distance from here to here. This is the real depth of this bubble. ಈ bubble the real depth ಎಷ್ಟು ಅಂತ ತಗೊಳ್ಳೋಣ, x ಅಂತ ತಗೊಳ್ಳೋಣ. ಹಾಗಾದ್ರೆ ಈ ಕಡೆ distance ಎಷ್ಟಾಯ್ತು, 24 minus x, because this is of 24 centimeter. Okay, so ಇದೇನಾಯ್ತು, ಹಾಗಾದ್ರೆ refractive index the formula use ಮಾಡೋಣ. When the object is in the denser medium, the refractive index of the medium is given by real depth upon apparent depth. So real depth is nothing but x from this face and apparent depth is nothing but 9 centimeter. And if you go from this face, that is the real depth is going to be, ಇಲ್ಲಿ real depth ನೋಡಿದ್ರೆ ಈ ಕಡೆ ಆಗುತ್ತೆ 24 minus x divided by this is this distance, apparent depth from this side is 7 centimeter. So ಹಾಗಾದ್ರೆ ಈ ಕಡೆಯಿಂದ ಆಯ್ತು x by 9, ಈ ಕಡೆಯಿಂದ ಆಯ್ತು 24 minus x divided by 7. So let us calculate this. N is the same from this side as well as from this side. That means ಈ ಕಡೆಯಿಂದ n calculate ಮಾಡಿದ್ರೆ refractive index ಅಂತೂ ಸೇಮ್ ಇರಲಿಕ್ಕೆ ಬೇಕು. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಇದು, equating these two equations, we can write this as x by 9 is equal to 24 minus x divided by 7. So this is 24 minus x divided by 7 is equal to x by 9 ಅಂತ ಬರೀಬಹುದು. 24 divided by, we'll bring this x on this side and take this 7 on this side. ಇದೇನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ this can be done as 24 minus x divided by x is equal to 7 divided by 9. This x is applicable for this also as well as this also. 24 divided by x ಇದನ್ನ ಹಿಂಗೂ ಬರೀಬಹುದು, 24 divided by x minus x divided by x is equal to 7 divided by 9 ಅಂತ. 24 divided by x we'll keep as it is, and x divided by x is 1, so we have kept 1 here, which is equal to 7 divided by 9 aita. So 24 divided by x, if you take this minus 1 on this side, this will be 7 divided by 9 plus 1. So if you calculate this, 24 divided by x, it is equal to 16 divided by, either calcium tegedre 9 agate, so it is going to be 16 divided by 9. So 24 divided by x is equal to 16 divided by 9. This implies 24 divided by x was equal to 16 divided by 9. We will take this x on this side. X is equal to 24 into 9 divided by 16 agate. So 24 into 9 divided by 16. X is equal to, this is going to be 27 by 2. That is calculate madidre, this is going to be 27 by 2 here. So that is 4 4s are 16, 4 6s are 24. So this is 2 3s are, and this is 2 2s are, 3 9s are 27 divided by 2. So x is equal to I to 13.5. That means from phase 1, this bubble, actually its real depth is at the distance of 13.5 centimeter. So to calculate the refractive index, then we can use the formula, this one, equation 1 use madana. Equation 1 x divided by 9. That is x is 13.5 divided by 9 is going to be 1.5. This is the final answer. I hope you got this. Let us go for this problem. A convex refracting spherical surface of radius of curvature 0.2 meter. There is a refracting surface. Assume that this is a refracting surface. Okay. Illi one denser medium is okay. The radius of curvature is given. The radius of curvature of this surface is about, say, this is the radius of curvature, and this is given 0.2 meter. Separates two media of a refractive index of 4/3 and 3/2. There are two refractive indices. Let us consider this is n1 and this is going to have the refractive index n2. Let me write this as 4/3 and this as 3/2. An object is placed in the first medium. That means E medium ಒಳಗಡೆ ಒಂದು object ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳ್ರಿ. So we'll write like this. Illi object ಇದೆ. So this is the object in the first medium that is having the refractive index 4/3 at a distance of 2 meter from the refracting surface. Andre E distance ಕೊಟ್ಟಿದ್ದಾರೆ, that is 2 meter from here to here. Surface, find the position of the image formed. The ray which is going to incident from here to here, it will come back. I mean, ಇದು refract ಆಗಿ ಇಲ್ಲಿ ಬಂದು ಬೀಳುತ್ತೆ. So this is the position of the image. We have to calculate this one. ಇಲ್ಲೆಲ್ಲೋ image ಬಿದ್ದಿದೆ ಅಂದ್ರೆ ಇದನ್ನು calculate ಮಾಡಿ. So to calculate this, let us go for this one. ಇದು formula ಏನು ಯೂಸ್ ಮಾಡೋಣ ಅಂತಂದ್ರೆ, refractive index of object space divided by object distance. This is minus and plus refractive index of image space divided by image distance is equal to change in refractive index divided by, this is R. So E formula is made. Let us write this as a first term and this as a second term. This is because this is a positive term. Refractive index of image space divided by image distance. Image distance is denoted by the letter V and object distance is a U. So U is a negative because according to the sign conventions, the object is in the left side of the pole. Therefore, this is going to be negative. So ಹಾಗಾದ್ರೆ ಇದನ್ನೆಲ್ಲ substitute ಮಾಡಿದ್ರೆ ಇದಾಗುತ್ತೆ. So this is going to be, ಇದನ್ನ ಮೊದಲು ಬರ್ಕೊಳ್ಳೋಣ, n2 divided by V minus n1 divided by U is equal to n2 minus n1 divided by R ಅಂತ. So this can be done as, ಇದರ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ, that is n2 is 3/2 divided by V minus n1 is 4/3 divided by U, that is minus U. U is given, sorry, U is given here. this is minus 2, and this is equal to n2 minus n1, that is 3 by 2 minus 4 by 3 divided by r. So r value is also known, that is 0.2 meter. So substituting all the values, we are going to get, see, 3 by 2 is nothing but 1.5. 1.5 divided by v. Then calculate madadre, this is going to be 1.33 divided by minus 2. This was minus here, is equal to 1.5 minus 1.33 divided by 0.2. Substituting all the values clearly, and we'll, on calculating, we'll get a v is equal to 8.9 or approximately equal to 9 meter. Okay, I hope you got this. Then image is formed in the denser medium, that is in another medium. Image is formed in medium 2. I hope you got this. Okay, this problem is very similar to the fourth problem what we have solved before. That is, a small bulb is placed at the bottom of a tank. Once again, consider there is a tank here. Illondu tank ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಈ tank ಒಳಗಡೆ at the bottom there is a small bulb placed. Okay, consisting of water to the depth of 80 centimeter. This time the height is changed, that is agle problem ಒಳಗಡೆ ಅದು 1 meter ಇತ್ತು, ಈಗ ಇದೆ 80 centimeter. Let us go from here to here. This is about 80 centimeter. What is the area of the surface of the water through which light from the bulb can emerge out? ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಇದೇನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ರೇ ಈ ಕಡೆ ಏನು ಹೋಗಿದೆ. So this is the ray which is traveling from denser medium to rarer medium. At the critical angle, this is going to graze like this. That means the ray which is going to fall soon after this is going to bounce back to the same medium. That means this is the last ray which is going to come out. On the same other side also we are going to have this structure. ಈಗ ಇದರಿಂದ ಸರ್ಕ್ಯುಲರ್ ಒಂದು ಪ್ಯಾಚ್ ಬಿದ್ದಿರುತ್ತಿಲ್ಲ, ಈ ಸರ್ಕ್ಯುಲರ್ ಪ್ಯಾಚ್ ಇಂದ ಏರಿಯಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. ಸೇಮ್ ಆವಾಗಲೇ ಏನ್ ಮಾಡಿದ್ವಿ ಅದೇ ತರ ಇದರ ರೇಡಿಯಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ, ನಂತರ ಇದ್ರ ಹೈಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೆನ್ ಯು ಕ್ಯಾನ್ actually calculate this c, and after calculating this you can find out the area also. Radius calculate ಮಾಡಿದ್ರೆ ಏರಿಯಾನು ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. So use the formula sin of c is equal to 1 upon n. This implies c is equal to refractive index is given, that is 1.33. That means this is going to be 1, c is equal to sin inverse of 1 divided by 1.33. So this is going to be sin inverse of 0.7518. So c value is found to be once again 48.74 degree. So this is the answer of the c. The c calculate ಮಾಡಿದ್ವಿ. ಹಾಗಾದ್ರೆ next ಹೋಗೋಣ r is equal to ಏನಿರುತ್ತೆ h tan of c. This is h is 80 centimeter. That means 0.8 meter into tan of c, it is tan of 48.74 degree. So if you calculate this, it is going to be 9112 meter. This is the radius. If you know the value of the radius, then calculate the area. Since it is a circular patch, therefore this is pi r square. This is going to be 3.142 into 0.9112. This is going to be 2.60 meter square. This is your final answer. Let us go for the another problem, that is what is the focal length of the convex lens? There is a convex lens of focal length 30 centimeter. Let me go for this. Focal length of convex lens, that is f convex, is equal to 30 centimeter, and in contact with the concave lens of focal length, that means there is another lens which is concave in nature, which is going to have the focal length of 20 centimeter. Of a system is the system of, okay, let us first find out the focal length of these two combination. Focal length is formula ಏನಿತ್ತು 1 upon f effective, this is equal to 1 upon f convex plus 1 upon f concave ಮಾಡೋಣ. So this is going to be 1 upon f convex. Since this concave is a negative, focal length for the concave lens ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಈ ನೆಗೆಟಿವ್ ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು we can write this as f concave. Okay, so therefore you substitute the values. 1 upon f effective is going to be, that is 1 upon this f convex was 30 minus 1 upon this is 20. Okay, so if you calculate the effective focal length, then f effective is going to be 60 is the LCM. ಮೇಲ್ಗಡೆ ಏನಾಗುತ್ತೆ 32 minus 23. So therefore this is minus 1 divided by 60. 1 upon f effective ಏನಾಯ್ತು ಇಲ್ಲಿ 1 upon 60 ಆಯ್ತು. ಹಾಗಾದ್ರೆ f effective ಏನಂತ, f effective is going to be minus 60 centimeter. See, if the combination is going to have the negative sign, the focal length of the combination is going to have the negative sign, that means it is going to be a diverging lens. Our lens in the nature of the diverging. If it is positive, then it is going to be a converging lens. Okay, so hope you got this. We'll go for the next problem. Okay, let us go for the another problem. This is a very similar problem to the previous problem. It's the same, only the change is a small change is there. We'll see what is that. A concave lens of a focal length 0.1 meter is placed in contact with the a convex lens. This is going to be a convex lens of focal length 0.1 meter is placed in contact with the concave lens of a focal length 0.12 meter. Find the focal length. Okay, find the focal length. Okay, this is repeated here. That's all. Find the focal length and the power of the combination. An object is placed at a distance of 0.2 meter from the combination. Find the nature and the position of the image formed. Okay, let us go for this. ಮೊದಲು ಏನು ಮಾಡೋಣ ಅಂದ್ರೆ ಎರಡು ಲೆನ್ಸಸ್ ಇದಾವೆ. ಒಂದು ಲೆನ್ಸ್ ಏನಿದೆ ಇಲ್ಲಿ ಕಾನ್ವೆಕ್ಸ್ ಇದೆ, ಇನ್ನೊಂದು ಲೆನ್ಸ್ ಏನಿದೆ ಅದು ಕಾನ್ಕೇವ್ ಇದೆ. ಸೊ ದೀಸ್ ಆರ್ ಕಂಬೈನ್ಡ್ ಲೈಕ್ ದಿಸ್. Okay, so once again we are going to have the same formula. 1 upon f effective is going to be 1 upon f convex minus 1 upon f concave. ಅದು ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಆಗಿದ್ರೆ ಯಾವಾಗಲೂ ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಹಾಕಬೇಡಿ. So therefore this is 1 upon convex minus 1 upon concave here. So this is going to be 1 upon 0.1 minus 1 upon 0.12. 1 upon 0.1 is nothing but 10, and this is going to be 8.33. So therefore you can directly calculate the power, that is 1 upon f effective is nothing but this is only the power of the combination. Therefore power is going to be 1.67 diopter and 1 upon f effective. So if you want to calculate the f effective, then it is a reciprocal of this. So 1 upon 1.67 you are going to get the answer, that is 0.59 meter. So here f effective is going to be 0.59 meter. ಈಗ ಹೋಗೋಣ position of image position calculate ಮಾಡಲಿಕ್ಕೆ use the lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. So substitute the values here. You know the value of f 0.59 ಇದೆ, calculate ಮಾಡ್ಕೊಂಡು ಬಂದಿದ್ದೀವಿ ಈಗಷ್ಟೇ. 1 upon v, it is 1 upon 0.2. Okay, sorry, this is 1 upon u value is given, that is 0.2. ಇದು ಈ ಕಡೆ ಇತ್ತು, ಈ ಕಡೆಯಿಂದ ಇಲ್ಲಿ ತಗೊಂಡು ಬಂದ್ರೆ ಇದಾಗುತ್ತೆ positive 1 upon 0.2 plus is equal to 1 upon v. We are now interested to calculate the value of v. 1 upon v is equal to 1.69 plus 5. So therefore this is going to be 6.69 is equal to 1 upon v. So v is equal to 0.149 meter. See here, in this case v is a positive. In the previous problem v was a negative. So if the v is a positive, or else if you go for the combination of the lenses, that is focal length positive bandre real image formation ಮಾಡುತ್ತೆ. focal length negative ಬಂದಿದ್ದೀನಾದ್ರೆ ಅದು virtual image formation ಮಾಡ್ತಿತ್ತು. ಹಾಗಾದ್ರೆ focal length combination ಅಲ್ಲಿ ಇರೋದು ಅದು negative ಬಂದ್ರೆ it is going to be a diverging lens. If it is positive, it is going to be a converging lens. There is a short note written here. Let us go for that. Let us go for this. In combination of convex and concave lens, when it is going to be a diverging lens and form the virtual image, and when it is going to be a converging lens and produces the real image ಅಂತ ನೋಡೋಣ. ಈಗ ಕಾಂಬಿನೇಷನ್ ಒಳಗಡೆ ಯಾವುದು ಫೋಕಲ್ ಲೆಂತ್ ಹೇಗಿದೆ ಅಂತ ನೋಡಬೇಕು. ಇಫ್ ಎಫ್ ಕಾನ್ವೆಕ್ಸ್ is greater than f concave, then effective combination ಏನಿರುತ್ತಲ್ಲ, effective lens ಏನಿದೆ, this is going to be diverging lens and produces always virtual image. ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ಹಾಗಾದ್ರೆ ಎಫ್ ಕಾನ್ಕೇವ್ ಏನಾದ್ರೂ ದೊಡ್ಡದಿದ್ದು ಎಫ್ ಕಾನ್ವೆಕ್ಸ್ ಏನಾದ್ರೂ ಸಣ್ಣದಾಗಿದ್ರೆ ಅವಾಗ ಏನಾಗಿರುತ್ತೆ, ಎಫ್ ಎಫೆಕ್ಟಿವ್ is going to be, that lens is going to be a converging lens and this is going to form the real image. So these are the problems which are from the ray optics. I hope this is going to help you for the examination, board examination now. All the best.